The United Nations 2030 Agenda for Sustainable Development, adopted by all United Nations member states in 2015, shares a blueprint for human prosperity. Enshrined within it are 17 goals that seek to grow global peace and prosperity: clean drinking water, education, equality, environmental conservation, and so on. Can we assume our activities well away from planet Earth in space exploration do not play a significant part? Well, it is arguably a lot more interwoven than this. Our relationship with space could help us achieve our goals on planet Earth, or it could hinder them. Let's lower our gaze for the next few minutes and consider how space exploration might be impacting life on Earth. This is ASU. When I ask the question, how does space impact life on Earth? It's worth us questioning whose life we're talking about. There are, after all, roughly 8 billion of us. I find the United Nations Sustainable Development Goals a useful proxy for the ideal goals for a sustainable future for all of humanity. The SDGs are 17 ambitious goals concerning our world's most important social, economic, and environmental issues. All 191 UN member states, representing over 99% of the world's population, have committed to try achieving these by 2030. There are aspirations such as SDG 2, Zero Hunger, SDG 7, Affordable and Clean Energy, or SDG 13, Climate Action. Space technologies already contribute greatly to the accomplishment of these global goals. However, these technologies can also pose issues that are worth considering. Perhaps the most significant space technology for the SDGs is Earth observation satellites. A wide array of satellite data is central to how governments currently monitor progress for nearly all of the 17 SDGs. EO is used for nearly half of the UN's 169 targets and 230 indicators, but most especially the environmental goals. Especially with lower barriers to the launch and manufacture of satellites, precise, real-time data collection is becoming more accessible. And this is especially important when monitoring environmental conditions in unpopulated regions that may actually be the most sensitive to climate change, like Antarctica. Furthermore, satellite data is empowering both communities and countries throughout the world to use insights from satellite data to make better policy decisions. Real-time EO data is even being used to stop everything from illegal logging to sex trafficking. At the same time, it's worth thinking about some of the risks that come with this new technology. Satellite data is an incredibly powerful tool. Camera resolutions now are powerful enough to capture imagery on the order of centimeters. That corresponds to a huge loss of privacy. However, the risk that I find particularly salient is that with the ability to make public policy decisions based on real data, a traffic control engineer could now hypothetically count the number of cars on the road during rush hour. My concern is that it will encourage policymakers to stop talking to real people. It's easy to imagine that the time-consuming task of going out, asking everyday people to explain in detail why social problems occur, and sorting through the disagreements and the noise, it's much easier for a bureaucrat to pull open some satellite imagery, run some software analysis, and then make incredibly impactful decisions without consulting the local population. While the impact of EO satellites on global monitoring is perhaps the most significant impact that space technologies are currently having on the SDGs, there are numerous other intersections. One very active and promising area of research is in microgravity healthcare. Biological systems in near weightless conditions see increased virulence and accelerated cell growth. This could increase the effectiveness of drug delivery systems and other biotechnologies. Stem cells grow better in space. Microgravity also modifies the characteristics of certain materials, allowing for the creation of materials and manufacturing techniques not possible on Earth. But what would happen if there were fantastic benefits of healthcare and manufacturing in microgravity and the number of rocket launches increased exponentially? Think that the burning of fossil fuels in the 19th century had not made a noticeable impact on global temperatures, but the scale was smaller. Our world burns over 15 times the amount of fossil fuels annually as compared with the year 1900. The space industry presents that same type of risk. Rocket emissions have been shown to have problematic effects in the upper atmosphere, especially the ozone layer. However, in 2021, there were only 144 rocket launches. What would happen if rocket launches began to approach the scale of commercial airflight, which, in the same year, had over 20 million flights? We don't really know, but it does seem plausible that advancements in microgravity healthcare would benefit, at least initially, the well-being of individuals in spacefaring nations, at the expense of the environmental conditions and thus the well-being of individuals in non-spacefaring nations. The UN SDGs are an impressive attempt to change the world for the better, a way to improve lives and environments at scale. The use of space technology is going to play a part in this process. It will allow us to support and monitor progress. It will provide the backdrop through which we can achieve these higher goals. Progress, however, both technological and humanitarian, is not linear and it is not one-dimensional. Space exploration can, and should, benefit the human race, but we can easily lose this opportunity if we don't manage it well. Let's make space count. This was ASU. Thank you for watching.